Kayla, a Year 7 student, displays a variety of different developmental issues. During this presentation, we will examine two domains of Kayla's development, her cognitive and socio-emotional development, and suggest some strategies teachers can implement to assist Kayla. Kayla complains of forgetting class content and not being able to keep up, especially in her mathematics and science classes, even though she likes the subjects. This suggests that she could be experiencing problems relating to her cognitive development, especially in regards to the limits of her working memory. This can be explained using cognitive load theory. Cognitive load theory suggests that when learning takes place, there is a load placed on a person's working memory that is known as cognitive load. When working memory is overloaded, then learning cannot take place effectively. It is possible that in Kayla's maths and science classes, the cognitive load placed on her working memory is too heavy. To assist Kayla, her teacher can implement classroom strategies that aim to reduce and manage cognitive load. The advantage of classroom strategies in this case is that they will assist all students with learning more effectively, not only Kayla. There are two types of cognitive load that the teacher can manage: intrinsic cognitive load and extraneous cognitive load. Intrinsic cognitive load is the load placed on the working memory by the nature of the learning task. Its main generator is element interactivity, which refers to the way in which individual elements of a task interact with each other during learning. Tasks with low element interactivity, which generate a low cognitive load, have elements that can be learned in isolation, while tasks with high element interactivity, which generate a high cognitive load, have elements that must be assimilated simultaneously. The two subjects that Kayla is struggling with, maths and science, in general involve learning tasks that have high element interactivity and therefore generate high intrinsic cognitive load. One strategy that can be implemented in the classroom involves attempting to reduce intrinsic cognitive load by reducing the element interactivity of a learning task. This can be done by presenting content in a stepwise fashion, rather than all at once. We'll use an example from basic chemistry to demonstrate. Covalent bonds are chemical bonds that involve atoms sharing electron pairs. They're represented like this. If you are presenting this information all at once, you would maybe begin with the terminology and the diagrammatic representation and the description of the chemical bond. This would have high element interactivity, as grasping the meaning of the diagram, the bond, and the term covalent bond are all dependent on each other or meaningless without each other. Dinelli and Reed suggest a different way of teaching covalent bonds, a stepwise presentation of content. In a stepwise presentation, pieces of content are taught as coherent chunks, which are standalone and build on each other. As you can see, this reduces element interactivity involved in the learning process, as the information is learnt piece by piece rather than all at once. Other strategies that could assist Kayla in managing cognitive load involve minimizing extraneous load. Extraneous load is additional load placed on the working memory by poor instruction. In maths and science, one of the most common generators of extraneous load that can be easily reduced is described as the split attention effect. Split attention is when the student has to integrate two sources of information in order to understand or solve a problem. Take, for example, this problem from maths. In the first example, extraneous cognitive load is generated because the problem statement and the formula are presented separately, meaning either the problem statement has to be memorized or the student needs to keep referring back and forth between the two. By comparison, in the integrated example, the problem statement and the formula are presented together, which has been shown to eliminate extraneous cognitive load.